niks op je laptop.
Ja, werkt zo. Even kijken.
Goed is, dat is prima. Ja, het blijft toch?
Ja, mijn laptop is een beetje vasthangen. Lekker. Twee registratie en een andere 95.
Even kijken wat ja, maar dus er is niet heel veel documentatie, maar dus gewoon
Hoor je wel iets of niet? Hoor je überhaupt geluid? Is het beter? Ja. Ja, dat vind ik ook vaak.
I don't need to push any button, right, to activate it?
No.
It's not. Can you try it online?
Okay, yeah.
However,
So,
yeah.
yeah.
We cannot see.
was maar 15% van wat ik zeg. Die is veel sterk. Joran mag niet uit. Dat is wel belangrijk. Kijk hoe sterk. Ja, dat is niet man. Dat is eigenlijk al lang. Zie je dat? Die is echt zo bij. Wat? Kun je dat daar even vertellen? Iedereen wil weten. Jan is sterk. Nee, dat is echt prachtig. Dat is echt veel leuker. Ik ga dus met afgelegd worden dat ik je hoofdkant was.
Can I just copy the whole folder?
Yeah.
It's maybe best if I put it on my. Then I will also put it on the wiki, such that everybody can.
Yeah. So after this, we can just part of styles from the team.
Yeah, sure. Yeah, we'll just put them on. I think on our wiki, the RoboCup wiki. There you can actually also find all the slides of previous years.
Okay. Yeah. Great. Looks like it's faster.
Yeah. But we're not there yet. Let's see. Alright, okay, so this one.
So the next one is Thuy.
Yeah, then you
next
begin
one.
on associate. So you can check if it's okay.
Yeah, okay.
You want to disable the sound?
Yeah, it looks very noisy.
Do you need it for other videos or no?
Sorry?
Do you need it for other videos or you don't?
No, no. No, I don't need any sound.
Okay. So then I think it's best. Oh, wow.
Actually, I think because this video cannot play, I have to. And maybe I'll come here and then press it so that you can play it.
Yeah, if you can do that.
Yeah,
Or I can also be here if you want.
okay, yeah. Because if there are two videos, I think the second one will play automatically, but the first one I don't know why it was not playing.
Maybe it's better if you do, by the way, because then I also know when. Yeah, because then you know when. So maybe that's better.
Okay, yeah.
So just
okay.
come here and put it.
Okay.
Moreover, if you can stand there, I put the marker there.
Yeah.
If you can stand near the table, near that
Okay.
mouse pad.
Okay.
Be
Okay.
great.
Great.
Yeah, so it's
Okay,
working
yeah.
everything?
It's working, yeah.
Yeah?
Right.
Great.
Okay. Thank you.
No problem. Let's see. Let's start with this one. VGA.
Mag ik aan mijn mail even?
My main.
Oh, ik juist wel gemaakt. Ziet eruit als ik het echt lang nog even werk.
Ja, dat is zo.
Hey, zit je met Twitter er ook op?
Heb je Twitter?
Ja, zeker.
Waarom volg je mij niet?
Omdat ik niks met Twitter doe, maar ik vind Twitter echt een hele vervelende manier van communiceren. Zeker aan Facebook, ja, Facebook vind ik het niet eens.
Ja. Ja. Ja.
Maar zit er wel eens op, Paul?
Wat zeg je?
Zit er wel eens op?
Op Twitter? Ja, zeker.
Ja, wat dan? Serieus?
Ja, zeker.
De reis was veel lekker vandaag.
Je hebt dus 3 berichten. Ja, dat is wel.
Dat is serieus.
Ja.
Waarom is het niet Wouter in 1991 onderscore MSL?
In 1991.
Waarom moet het 1992 zijn? Dat is 92 kan er ook. Klopt. Wouter is een boy.
Ja, bij team was het wel eens als het dan zo rond, ja, bij team heb je rond het achtstreepje of achtstreepje. Dat is zo grappig.
Ook die stijl. Wanneer er een lijn komt en daar is even uit blik. Die mijn gast zitten aan die best is XX underscore Luce underscore XX en wat ook dus van. Nee, sorry hoor.
Ja, dat was de Lina, dat is de ring van mij, die had ik nog tot de 20 of zo.
Ja, kom op.
Lina, daar zit een heel dossier. Ik kan zo niet.
Ik heb een Wouter en een Twitter account daar, maar ik kun er even praten.
Hij snapt het niet wat.
Ja? Ja, nee, hij lacht erom, hij snapt niet. Dat is
Ja,
anders.
ik vroeg het, zei zie je de fouten zijn? Ja, zie je de fouten? Toch?
Die zegt al niet.
Nee, hij zei, ja, ik kan wel Nederlands, maar hij is alleen niet altijd.
Hoe moet jij nou zeggen, heel nieuw? Ja, maar ik heb er al bij vast.
Ja, dank je.
Heel nodig?
Ja, kom jij erbij staan dan?
Ik wil een drankje doen.
Ja, zeker. Kom maar.
Ik samen met Marion. Oh, die begint zo met de camera te zwaaien. Zet me op zelf staan. Dan kunnen wij samen even drankje. Ja, Joran wil foto's maken. Hij weet niet de camera werkt, net hetzelfde. Alleen hij is nog best vaak voor de Omnia. Dat scheelt misschien. Ah, zegt
So, everybody ready? Well, then we start with the presentation actually of Tech United. So, in the coming 25 minutes, I want to tell you a little bit about our latest developments. We made mostly from Japan after the World Cup, and then I will also elaborate a bit more on our ideas about this common simulator ID. So let's see. So Team Tech United, most of you will already know us, but here are some interesting statuses maybe. So we became first in the Portuguese Open this year actually. Unfortunately, second in RoboCup 2017 in Japan. To update you, currently we have 24 team members, of which 5 new team members, among which some of them are actually here. At this moment we have 2 bachelor students. This number will probably stay about the same, but we'll also do some more master students. And there are actually 3 and maybe even 4 PhDs already working also on Tech United, so that's really good. Aside from that, we also have an interesting cooperation with the Fontes team. We're trying to make here a new goalkeeper. We're working with the mechanical engineering department from Fontes. And one thing we're really proud of is that we've got a new soccer field actually, so a totally new cover for our soccer field. The old one had some black stripes on it, you probably all know that. Now we got a new one, it's brand new, and we hope to keep it that way, with the emphasis on hope. Let's see, so I listed some of the current focus points of Tech United. I actually enlisted all of them. Some are marked in red. I will come back to them in a little bit more detail because I think they might be interesting for you. And the others see just as a notification. So currently we're working on more back passes. Actually in the final this was one of the things which went a little bit wrong. We intended to make some more back passes, but that didn't happen. So we already fixed that bug. Also our response after catching the ball is a little bit too slow, so we want to increase that one. Configurable strategy, well, you might all know what that means. I will come back to that in a moment. We're doing some stuff in the world model, so currently we're looking in how to even incorporate more information which comes from the Kinect to also incorporate that in the world model. Currently it's mostly the OmniVision unit which delivers data to the world model. Of course we can utilize this powerful sensor even more. That's what we're aiming here for. And also we're currently looking at the tuning of our filters in the world model. Then on the skill sets, we're working on this human dribble. Everybody knows Water can actually do it, so we want to do it as well because we think that this regaining this new 3-meter dribble is really an important thing. So that's what we're working on. I don't think this comes as a surprise to many of you, but and also we have a very nice IMU in which there is a gyro. Currently it's not used, but if we are rotating, we want to make a very accurate, very quick shot. So currently we're looking into how to improve our orientation estimation with this sensor. Then on the low level and hardware, we're aiming for more accuracy in our shots, and we're also working on the 8-wheel platform, which you might all know, but I'll have a short video which shows you the principle. And then we're also working on some low-level motion control improvements, which go into the similar area as ASML was talking about. So we're trying to implement cascaded control there. Oh wait, one too much. In Vision, we're currently working on recognizing opponent number plates or opponent labels. And we have already finished this one, a new ball calibration tool. So that's a lot. So if you want to know things about the black items on the list, please come to me or one of the team members of Tech United. And then now I will continue with some of the red items on the list. So configurable strategy. So after, actually before Japan already, but in Japan it also became quite clear that we were a little bit predictable. We got as a feedback to our final with the water. And also, we already had the idea for a longer time that we wanted to implement these kinds of set plays. So I Googled it yesterday. This is a basketball example where you can actually see that one moves down, screens another one. This is something they also use in soccer. And that's also what we want to start implementing more and more and more, because we actually came up with some of those nice set plays already. So now it's how we're going to put that into our strategy, of course. And of course, this might be an interesting point to also start learning from our games. So if something doesn't work during a game, we have to change it, and maybe even during the game. And this might be a nice starting place for that as well. So yeah, we've identified a nice solution. We already did that before RoboCup Japan. It's actually the solution which Lotte de Koning worked on. So it's the paper she wrote, skills, tactics and plays for decentralized multi-robot control in adversarial environments. If you want to know more about that, Lotte is there in the corner. So she can tell you everything about it. What we are actually doing is that Lotte has cooperated with the CMU Dragons team, the small size league team. And she had a look at how we can actually use their strategy, way of strategy, so their configurable strategy, how to apply that in an MSL context. So currently we have most of the STP framework, so the skills, tactics and plays framework is in there. So we have a whole playbook with these set plays, and from that we can select a certain play, then assign roles, and then we can actually execute that play. That's really nice. Most of it is already implemented. We're currently also already making plays. So that's at this moment mostly based on the RefBox tasks, but that of course will be extended. One thing we're currently working on is the role assigner to make that cooperate with the rest of the framework. Let's see, so the 8-wheel platform, I just saw some people looking like a bit confused. Probably they don't know the 8-wheel platform yet. So this is a video of it. So here you see it, and it's actually a platform which has these 4 smart wheel units, as we call them. There's even a commentator in the video. So this robot is extremely, it can actually do almost everything our 3-wheel platform can do as well. It's what we call semi-holonomic. How does it look? So just for those who missed it maybe, we have 4 smart wheel units. Each smart wheel unit consists of 2 wheels, which are connected to a shaft, which is in between those 2 wheels, and that shaft in the middle is connected to a pivot point to the rest of the robot. The 2 wheels can be actuated independently, but what happens if we actuate them both at the same time, in the same direction, and all the wheels are in the same direction, the robot will drive in that direction. If we want to go into a different direction, we have to change the orientation of the wheel units. And that's where the independent actuation of these wheels comes in, because if we spin them opposite, the opposite side of each other, then the wheel unit pivots around the central point, and then when we're done pivoting, we can go in that direction. Of course, that sounds very going straight and then to the left, but of course you can do some nice trajectory generation there, and hopefully we'll manage before the next tournament. So what we're currently doing is are currently looking on how to improve those wheel units. The ones you see in the video, which were used there, They had limited CPU power, so on the low level motion control, and we think we have found some ways to improve that. So that's what we're currently working on. And we still need, we're also working on it, but we had this question how to turn this robot you just saw into a real middle-sized league robot. So it needs to be able to kick, it needs to have a ball handling computer. So yeah, how to make such a robot. So currently we're also designing in that sense. So then the last part of the last item on the list, that's the recognizing opponent labels. That's mostly the work of Peter, who is over there. So if you have any questions about this part, you can also ask Peter about it. So what we did, we actually took a lot of photos of our robots, and especially making sure that the label of the robot, so the ones actually everybody needs to have according to the rules, is on the photo. Then we applied some distortion, rotation, scale, color, and shift to those photos. And actually, with all those different kinds of settings, of all those filters, I would say, then we can get actually 60,000 variations of a single photo. That means that if we have the ground truth for this photo, which is in this case magenta number 2, we actually have the ground truth for over 60,000 variations of that photo, which can look something like this. So this is probably distorted, has a bit of rotation, scaling, color shifting. So that's a distorted image, which gets then input into this neural network, which we then train with this information, of course, and then hopefully we can apply it to our OmniVision camera images. In that way, we can actually improve the tracking. We get way more information from actually our opponents, and hopefully that will improve the tracking, for example, in the world model. Just a quick status on this. I think that this is at the moment really difficult still to train this network, so we're still in the process of doing so. Then, of course, we had the idea of this common simulator, and I wanted to already, before tomorrow, also emphasize on our use cases for this common simulator. So, at our side, immediately we thought about this idea we had last year in Kassel, where actually Kambada and Tech United, we try to work with the Tech United simulator link, so actually providing a communication channel between the two databases of our agents. Well, I would say that was semi-successfully. In the end, some Kambada robots appeared in our simulator and vice versa. It was not ready to play a real game. But this is like already a starting point. You need these standard data encodings we talked a lot about. Apparently in some case even I think our world model coordinate frames were mixed up at some point. So yeah, these things, they are really important. But also, why did we do it? Maybe not all of you know why we do it. Well, actually, we have one very, I think most of you actually have this idea. We want to test more often. We're on the field, we have a very nice field there, I just showed it, new carpet, but there are only 5 robots there. And we want to do some more testing, and maybe also not only on the level of robots driving around, but also strategies. As we're also working on the configurable strategies, so we'd like to test those. And maybe not versus some old code we have, some artificial intelligence, but preferably versus Kambada, or versus Water, or any other team. So that's where we think that this common simulator really is really useful for us to test our strategies. Aside from that, and I think Carpenotum also mentioned it, we're also looking into how we can also use artificial intelligence on the strategy level. So also Peter is also working on this. So what we actually have at the moment, and I think we'll have a demonstration, looking at Peter, quick. Later. We'll do a quick, quick demonstration later. So suppose we have an OmniVision image. We can actually we have software to actually go to a simulator state. And from that we can make a lower dimensional state, which we can actually move into the deep Q learning recurrent neural network. And what that will do is actually for our robot, our current robot in the simulator. It will decide what the best next thing to do is. So go left at this moment is really simple. It's go left, go right, move forward or move backward. And then it will get into this new state, into this new state of the simulator. And that might be a state which is desirable or not. For example, you can imagine this if I'm trying to move away from two water attackers which are defenders, which are in my back. I want to turn around and try to see what I can do. Well, then it might not be desirable to turn around and just show the ball to them, because then they will have the ball in no time. So this is a way, this is a little bit the cost function we use for training. And this is actually an example we could use to train this neural network with. But currently, I noted it here also, we use an A-star algorithm in this simulator. And of course, what would be better to train against Kambada or water in here?